All right, my math 8 people. We got our last lesson in Unit 1. We're going to take another shot at the one solution, no solution, and infinite solution problems. All right, so I said last time that there are two steps of solving our multi-step equations where we might get infinite solutions or no solutions. And so here's our 2 steps where they might happen. And so let's look at what it looks like to get no solution or infinite solutions. Okay, so for combining like terms, over here, I'm ready to combine like terms. I've got a 3y and a negative 3y. The 3y and the negative 3y are going to cancel each other out. So I'm going to end up with 4 equals 4. So if the variables go away and we have a true statement, 4 always equals 4, this is where we would say infinite solutions. Now notice the pattern here. In combining like terms, if the y's, if the variables are opposites of each other, that's when we're going to get infinite solution or no solution. So in this one right here, the variables are opposites. Now let's look at the balancing one. So here we've got a problem. We're supposed to balance it at this point. I've got 6x over here, and I've got 6x over there. So when I'm balancing, I'm going to subtract 6x from both sides. And now my variables are disappearing because we've got opposites right here. Now when I've subtracted the 6x, I get negative 7 equals positive 7. Negative 7 never equals positive 7. That's a false statement. Therefore, on this one, we would say that there is no solution. Now let's look at the pattern. On the previous pattern, when we were combining like terms, the variables were opposites of each other. But when we're balancing and we end up with a no solution or an infinite solution, the variables are exactly the same. So that when you do the inverse operation and subtract it, that's when they go away. So when we're balancing, we're going to look for the variables having the same coefficient on both sides. And when I say the variables are the same, I'm really talking about the coefficients of the variables. The numbers out front. So here, the coefficients were opposites of each other, and that's why the variables went away. All right, so let's do some math puzzles here. So I've got 5x minus 4 equals ax plus b. Extra equations. All right, if the answer is no solution, solve for a and b. Okay, so this is a balancing problem. I got x's on this side and x's on this side. When we balance it, the coefficients of the variables need to be the same. So this is 5x. This one would also have to be 5x. So the a would need to be equal to 5. Because if I had 5x here and 5x here, when I do my balancing, the 5x's are going to go away. Now, what about the b for it to be no solution? Okay, after the x's go away, I want this to be a false statement. So the only number that b cannot be is negative 4 if it's no solution. So b cannot be negative 4. It can be anything else. So it could be 1, it could be 2, whatever. Anything but negative 4. So plus, let's just put in 5. Negative 4 is not equal to 5, so this would be no solution. So a b value that would work would be 5. 5 also works. Basically, we're saying anything but negative 4. All right, on the same problem. What if the answer was infinite solutions? On infinite solutions, we should end with a number equaling itself. So I still need to have the a value to be 5 because I need 5x on this side of the equation and I need 5x on this side of the equation. So x must be, or sorry, a must be 5. Now for it to be infinite solutions, I have to have the exact same constant number over there. So now when the x's, when we subtract 5x and the x's cancel each other out, we're going to end up with -4 equals -4. So the b value for this one has to be -4. All right, next problem. We've got 2 times 5x minus 6 equals ax plus 12. The answer on this one is going to be no solution. We need to find an a value that will make it no solution. Well, it looks like there's a little bit of distributing on this first side of the equation here. So let's go ahead and do that first. I'm going to distribute. I'm going to get 10x minus 12 equals ax plus 12. All right, so to get no solution, the x's have to cancel out. This is a balancing problem. So since it's a balancing problem, the x's have to be the same. The coefficients have to be the same on both sides. So if this one has a coefficient of 10, the a has to be 10 as well. So I'm going to make a 10. If a is 10, this is what the equation would look like. 10x minus 12 equals a is 10, 10x plus 12. When I subtract 10x from both sides, I end up with -12 equals positive 12. -12 never equals positive 12. That is no solution. All right, we got 3 more. And if you're working on this on your own, or maybe you're in another class, or maybe you're absent today or sick or whatever, and you're trying to keep up with the notes, try out the next 3. On number 3, infinite solutions, solve for b. Number 4, the answer is no solution, solve for a. And on this last one, we want infinite solutions. We want to know what a and b are going to be. All right, so you could pause it right here, try it out on your own, and then you can check your answers. So pause. Hopefully you've paused. Okay, so we're back. Let's go ahead and solve these. Okay, it looks like I got a little bit of work to do over here before I can find out what b is supposed to be. It's going to be infinite solutions for this one. So I need everything to be the same on both sides. So I'm going to start by distributing -3 to both of these. So I end up with 7 minus 3x minus 18 equals -3x plus b. So I would, at this point, combine my two like terms. I get -3x minus 11, because I'm combining my like terms there. Balancing, the x's are going to cancel. And I get -11 equals b. Okay, so what do I need b to be infinite solutions? To be infinite, b would have to be 11. -11. Next one. I've got an ax over here. I'm going to distribute. I want this to be no solution. So if I distribute, ax doesn't change. This is positive 21x. This is -42 equals -41. To be no solution, I want these to cancel. This is combining like terms. To cancel, this has to be the opposite of positive 21. A has to be -21. So that these two, this would be -21, this would be positive 21, it would cancel. then I'd only have negative 42 equals negative 21, no solution. So A is negative 21 on that one. Last one, I'm going to distribute. I've got negative 2x minus 3x plus 12 equals ax plus b. We're looking for infinite solutions. I want them the same on both sides. Let's combine these like terms first. I get negative 5x plus 12 equals ax plus b. If it's infinite solutions, the ax and this one have to match up, and the 12 and this one have to match up. They have to be exactly the same. So that means a must be negative 5, and b must be 12. We can plug it back in and see what we get. A is negative 5, B is 12, and yes, after I add 5x to both sides, I get 12 equals 12, infinite solutions. All right, that's all I got for you today. Math Hard, see you later. Bye-bye.